Microbes are organisms that are too small to see without a microscope, but they can eat plastic, cure diseases, and thrive in some of the world's most extreme environments. So scientists are now looking to microbes to help solve many of our most pressing problems, including climate change. Already, labs around the world are making incredible progress engineering them for different tasks. And joining us with a closer look at the possibility of microbes is Ronan McCarthy. He's a professor of biomedical sciences at Brunel University in London. Welcome to Your Morning.
Thank you very much, and very nice to meet you, Anne-Marie. Sorry.
I was going to say, all the way back in 2001, Japanese researchers discovered microbes that can consume plastic. So what does that tell us about the way the bacteria are evolving?
Yeah, absolutely. And I think you prefaced it really nicely by highlighting that microorganisms have evolved to colonize almost every part of our planet, from hydrothermal vents to Arctic permafrost. And part of the reason for that is their remarkable capacity to develop enzymes and different strategies to tolerate this relatively inhospitable environments. Now, clinically, this presents a massive challenge because when we develop a new antibiotic to treat an infection, bacteria can very quickly evolve to become resistant to that antibiotic, meaning it's no longer clinically effective. But from an environmental perspective, this presents an interesting prospect because I suppose since the last 100 years, when we've had the very sudden and rapid introduction of plastic waste into our environment, bacteria have then had to deal with this and evolve strategies to cope with this new substrate, this new substance that's in their environment. And researchers, as you highlighted in Japan, they went to areas where there were very high density of plastic pollution. So for one example, they went to a recycling plant and they actually found some bacteria growing on plastic in this recycling plant that could consume this plastic. Equally, in my own research, I've actually collected plastic that's washed up on the beach and isolated the microorganisms that were growing on that plastic and shown a remarkable microbial diversity of organisms that were essentially living off that plastic. So it's a very, very exciting prospect that we now have enzymes and bacteria that can potentially tackle the plastic waste problem. Because as you're well aware, less than 10% of our plastic waste is actually recycled, with the majority of it making its way into landfill.
Well, this is why a solution needs to be found quickly. You mentioned microbes evolve to survive off of what they encounter in their environments. And humans have fundamentally changed that environment, not just with plastic, but I'm talking about carbon pollution, increased temperatures, and more. What other challenges are we facing where microbes could be used as a potential tool?
Yeah, absolutely. So there's a range of different, I suppose, environmental pollutants that are a big challenge that microbes could be used to tackle. So one, for example, is the presence of antibiotics in our environment. They select for antibiotic resistance, which could ultimately make its way to the clinic. So microbes have evolved enzymes that can break down these antibiotics. There's also enzymes and bacteria that could potentially be used to treat oil spills and contaminated soil that's been contaminated with oil. And there's also some enzymes that have been identified and developed for carbon capture. One of the more interesting ones as well is algal blooms. This is something that many people probably encounter when they go to a lake and potentially see a sign saying no swimming because of toxins from an algal bloom. Well, this comes back to the evolution of bacteria again, because they've evolved to tolerate these algal blooms and survive in them, and by producing enzymes that essentially break down these toxins. So there is the potential that we could exploit these enzymes and deploy them in contaminated water bodies to reduce the amount of toxins in there, essentially making them safe again and making them more hospitable for the animals and wildlife that inhabit that water.
It really is, when you set it up that way, exciting to see what the potential of them are. Ronan McCarthy, professor of biomedical sciences at Brunel University in London. Fascinating discussion. Thanks for coming on this morning.
Thank you very much.
Hey, thanks for watching. If you liked this, be sure to subscribe here, or you can check out more Your Morning videos right here.